Good afternoon, student. Tangent law and tangent galvanometer. This is very important 5-mark question from your third lesson, 12th standard physics subject. Tangent galvanometer. This is the picture of tangent galvanometer. What is the uses of this tangent galvanometer? It is a device which is used to measure very small current. So, it's a device used to measure very small current. It is a moving magnet type galvanometer. Its working is based on tangent law. Very important law. Tangent law. What is meant by tangent law? So here this is very important 2-mark question. Tangent law is nothing but when a magnetic needle, here this is the magnetic needle, or magnet is freely suspended in two mutual perpendicular uniform magnetic field. So when the magnet or magnetic needle suspended two mutual perpendicular uniform magnetic fields, it will come to rest in the direction of resultant of the two fields. So needle or magnet suspended two mutual perpendicular uniform magnetic field means it will come to rest in the direction of the resultant of the two fields. This is the tangent law. Next, let B be the magnetic field produced by passing through the coil of the tangent galvanometer, and BH be the horizontal component of earth magnetic. B means magnetic field. BH means horizontal component of earth magnetic field. Under the action of two magnetic fields, the needle comes to rest, making angle theta. So, under the actions of two magnetic fields, the needle come to rest, making an angle theta with BH such that B is equal to, very important formula, B is equal to BH tan theta. So, now construction. Tangent galvanometer, shortly we can written this term TG, capital T, capital G, TG. TG means tangent galvanometer. Consists of copper coil wound on a non-magnetic circular frame. This is the non-magnetic circular frame. So, consists of copper coil wound a non-magnetic circular frame. The frame is made up of, this frame is made up of brass or wood. Brass or wood which is mounted vertically on the horizontal base table. This is the horizontal base table with 3 leveling screw here. This is a 3 leveling screw here. This is 3 leveling screws as shown in the figure. The tangent galvanometers pivot provided with 2 or more coils. Here 2 or more coils of different number of turns. Most of the equipment we use in laboratory consists of 2 turns, 5 turns and 50 turns, which are different thickness and are used for measuring current of different strengths. Pointer. Next, at the center, this is the center, at the center of the table, a small upright projection, this is the upright projection, is seen on which compass box, here this is the compass box, also known as magnetometer box, is placed. Compass box consists of a small magnetic needle, this is the small magnetic needle, which is pivoted at the center such that arrangement shows the center of both the magnetic field and circular coil exactly coincide. Exactly coincide. A thin aluminum pointer, this is a thin aluminum pointer here. Thin aluminum pointer is attached to the magnetic needle normally and moves over a circular scale. This is a circular scale. Moves over a circular scale. The circular scale is divided into 4 quadrants. The circular scale is divided into 4 quadrants and graduated in degree. This value is graduated in degree, which are used in measure the deflection of aluminum pointer on a circular degree. Next, degree scale. In order to avoid parallax error in measurement, a mirror is placed below the aluminum. Next, precaution. What are the precaution? There are four important precaution. First precaution is all the nearby magnets and magnetic materials are kept away from the instrument. Second important precaution, using sprit level, the leveling screw at the base are adjust so that small magnetic needle is exactly horizontal, and also coil mounted on the frame is exactly vertical. The third important precaution is the plane of the coil is kept parallel to the small magnetic needle by rotating the coil about its vertical axis. So the coil remains in magnetic meridian. Then the last important precaution is the compass box is rotated such that pointer lead pointer reads 0 degree to 0 degree, 0 to 0 degree. So this is the four important precaution of the tangent galvanometer. Very important precaution. Then only the tangent galvanometer properly working. So very important precaution. Then next, theory. The circuit connection for tangent galvanometer TG. This is the circuit connection. Here, this is the this is the tangent galvanometer. Here, this is a commutator key. Commutator key. This is key. This is battery. Then tangent galvanometer device. This is rheostat. Rheostat is the device which is used to varying the current. When no current is passed through the coil, the small magnetic needle lies along horizontal component of earth magnetic field. So the point is, when no current passes through the coil means the small magnetic needle lies along the horizontal component of earth magnetic field. When the current is switched on, the electric current will pass through the coil, the circular coil, and produce magnetic field. So current produces the magnetic field in the perpendicular direction. So automatically the magnetic needle produced due to the circulatory electric current is discussed. Now there are two magnetic fields, two fields which are acting mutually perpendicular to each other. They are, first point is magnetic field B due to the electric current on the coil acting normal to the plane of the coil. First magnetic field is due to the electric current produced by electric current. The magnetic field B due to the electric current in the coil acting normal to the plane of the coil. Next, second point is, already we know the horizontal component of earth magnetic field. So earth magnetic field is one magnetic field, another one magnetic field produced by the electric current. The next important thing, because of this crossed field, the pivoted magnetic needle deflected through an angle theta. When the current passing through the coil, automatically the needle deflected by the current, producing the magnetic field. Angle theta from tangent law, the equation, already we know the equation, B is equal to BH sin theta. When an electric current is passed through a circular coil of radius r having n turns, the magnitude of magnetic field at the center is B is equal to, this is very important formula, B is equal to mu naught Ni divided by 2r. N means number of turns, I means current divided by 2r means circumference of the coil. That means circular coil of radius is nothing but 2r. Yeah, r, circumference of the radius, circular coil of radius r having n turns. N is the turns of the coil. I is represent current. R is represent circular coil of radius. From equation 3.29 and 3.30, we get B is nothing but mu naught Ni divided by 2R is equal to BH tan theta. So now let me calculate the value of, calculate the value of horizontal component of earth magnetic field can be determined as BH is equal to, just here in this equation, BH is equal to mu naught into Ni divided by 2R into 1 by tan theta in Tesla, because Tesla is the unit of magnetic field. Thank you.